Welcome back to our videos on properties of real numbers. Right now we have just looked at our real number system. So we have irrational numbers and rational numbers that are distinct. They do not overlap. Within rational numbers could be integers. Integers could be whole numbers. Whole numbers could be natural numbers. Every natural number is also a whole number. Every whole number is also an integer, and every integer is also a rational number. All rational and irrational numbers are real numbers. So this is our real number system. And I now want to look at an example where we are trying to name all of the sets of numbers to which each number belongs. So if I look at negative 185, the way I want to work through this is I'm going to go to my real number system and I'm going to find the most inner place that I can define it, and then I'm going to define it out from there. So negative 185 is a negative number, which means it's not a natural number and it's not a whole number. It's not a ratio because it's just a single number being divided by 1 if it was written as a ratio. So this is an integer. So negative 185 is an integer, and I'm going to use the capital letter Z to express integer, as we've shown in our table, in our picture over here. So this is an integer. All integers are also rational. All rational numbers are also real. So this is an integer, a rational, and a real. Negative square root of 49, I first need to simplify the square root of 49. I know that the square root of 49 is 7, because 7 times 7 is 49. So this simplifies down to be negative 7. Negative 7 is an integer. It's a negative number, so it can't be natural or whole. An integer is the most specific in which it falls. All integers are also rational, and they're also real. Integers fall inside rational and real. The square root of 95. The square root of 95 can't be simplified. 95 is equal to 19 times 5. 19 times 5, neither of those values are a perfect square, so this is not, 95 is not a perfect square, so this is an irrational number. All irrational numbers are also real, so this is just irrational and real. If a number is irrational, it can't be any of the other number types. Negative 7/8 is a ratio of two integers, so this is going to be a rational number. All rational numbers are also real. The square root of 36 can be simplified to be 6. 36 is a perfect square. 6 squared is 36. 6 is a counting number or a natural number. That's its most specific number type. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers, and all rational numbers are real numbers. So this is all of the number types except irrational. 0 is not a natural number, but it is a whole number. 0 is the only whole number that is not also a natural number. All whole numbers are integers, all integers are rational, and all rational numbers are real. So to summarize how we go through these examples, you're going to go to your real number space, and you are going to find the furthest in place where you could define it. And then you are going to include all of the boxes which contain that number type. So if it's natural, it would be natural, whole, integer, rational, real. If it's irrational, it will only be real. Irrational and rational do not overlap. They're completely separate. But all of these others inside rational have an overlap and lay inside of each other.